Hey everyone, welcome back to another Greenfoot lesson. We are studying object-oriented programming through Java using the Greenfoot development environment. In our last lesson, we looked at creating a dog that would follow or walk around as it saw fit the environment, and the dog would turn whenever it encountered a wall, or we said don't go on the grassy area, right? So in this lesson, I want to add some more stuff for our dog to do. And in the meantime, we're going to learn about a new kind of data structure that is similar to an array, but a lot easier to use and much more versatile. So the first thing I want to do is make it to where my dog can eat something. Okay? So let's take a look at our dog class. And right now, all we have in our act method is to move and turn, but I want to make it to where it can eat. So first, actually, before we even do this, we need to make something for the dog to eat, and that's going to be another actor. So let's make a new subclass. So right click on actor and select new subclass. And look, we've got food right there. And you can pick anything you want. I think the dog will want to eat a burger, and I'm going to call this the burger class because I don't feel like spelling hamburger every time. Okay, so we've got a new subclass of actor called burger, and I'm just going to leave it alone. It's just going to be a blank act, so it's just going to be able to be positioned somewhere. All right, now that we've got a burger, let's make a method called eat. So our act will now move and turn, and then we'll eat if possible. So let's write the code for that. Notice it's got an error because I haven't written it yet. So I'll say public, and we're not returning anything, so void for not returning something, and I'll just say eat. So there are lots of different ways that we can do this. I want to explore just a couple of them right here and kind of look at the advantages and disadvantages of them. The first one I'm going to do is the simplest one. I'm just going to say remove touching burger.class. So remove touching. Remember, you don't have to have any of these methods memorized. They're all right there. Just click on actor. You've got all of these available to you. Let me enlarge this just a little bit here. You've got remove touching, and remove touching removes one object of the given class. So you have to give it a class type, and it will remove anything if it's touching something of that class. So I just said remove touching burger class. Okay. So, I don't want to undo. Let's redo that. All right. Now, let's add some burgers. So I'll add a burger here, and if I just hold shift, I can add another burger there. Oops, I put two there. Trying to move you over here. There we go. Put one there maybe. Another one here. There. There. And maybe one right there. And let's put a dog out. I tell you what, let's put two dogs out. How's that sound? And let's run. And as you can see, as the dogs interact with the burgers, they simply remove them from the world. All right. So that's pretty straightforward, I hope. Okay, let's go and let's look at another way to do that. So that's the simplest way. The problem with that, though, is the remove touching. I wish it returned something. I wish it returned like a Boolean true, but you'll notice it returns void. It's got that protected again. Don't worry about that, but it's void. So we don't actually get any real information there. We run the method, it does something or it doesn't, but we don't get to. And I wanna keep score. So we want to make it to where we can really tell when something happened. And I want to record it. So first thing I'm going to do is I'm going to make another variable. Actually, we don't even have a variable really. So let's make one private int. I'll call this burgers eaten. Okay, and then because I have a variable, we've had this whole time, we've had this constructor right here. We've had public dog, with no parameters, that all it does is call the superclass of actor with no parameters. Well, now we're going to do something else. Now, super always has to be the first line of code if you're going to have it anywhere. So we have to move down to here. And I'll say burgers eaten equals 0. So now you can see that we're setting our burgers eaten to 0 when the dog is created. Now, instead of remove touching, I'm going to do something a little bit different. I'm going to say burger. Actually, I can't. I have to say actor burger gets get one intersecting object of type burger.class. We used this method earlier with the grass, but now we're using it for the burger. And I also would like to remove the burger, but also score it. So I'm going to say if burger does not equal null, now we can increase our burgers count. So I'll just say burgers eaten plus plus. And then I could call the remove touching method. But since we've already got an instance of the burger, I want to show you another way to remove something that gives us more control. But to remove an actor is actually part of the world class. You'll notice that we have remove, it's not remove actor, it's remove object, and it takes an actor. So we're going to use that method, but that belongs to the world. So remember, if we want to call a method that we wrote in this class, for example, we're writing the method eat, you want to call the method eat, you just say eat with parentheses or whatever parameters it needs. If we want to use a method from the superclass, such as get one intersecting object, I simply call get one intersecting object. So anything from the superclass or any of my superclasses that I'm extending, I just say the method name. Anything from this class, just say the method name. But world is not a superclass of dog, right? World is a totally different thing. I need to get an instance of the world and call the method on that instance with the dot operator. So let's see how I do that. Well, there's a method for that as well. So you'll notice it's called get world. And what's it return? A world. We can also get world of our subtype and give it neighborhood, and it returns us a typed world. But let's not. We don't need that right now. We just need get world. So I will say world. I'll just call it W equals get world. So this returns a reference. Oh, just get world. It returns a reference to the world that we're in right now. Now that I have a reference to that world, I can call that method, which in world is remove object. So I'll say w dot remove object. And what do I want to have removed? I want the burger that I found to be removed. Okay? All right. One last thing to do before we test this. We've got a private variable. Let's give everybody access to it by making a accessor. So we'll say public. It's going to return an int because number of burgers eaten is an integer. And I'll call it get burgers eaten. Doesn't require any parameters, and I'll just simply return the variable value. So that's it. We've done those little accessors before. I'll compile it. And now I'm going to put some burgers everywhere. And having a count is going to make things a lot more interesting because we're going to be able to kind of compare to different ways that these dogs behave and how many burgers they get. Remember, we're working on simulations right now. Simulations is a very important part of computer science because it's how we try and model the world around us with simulations so we can try and make predictions and prepare for bad things or promote good things. So I'm going to put one dog there. I'm going to put another dog here. And we'll go from there. All right, dogs, do your thing. You'll have to pardon how slow mine's running. It's I am running 2 different versions of Greenfoot at the same time to look at my notes and recording all at the same time, and I'm really kind of pushing my computer to the limit. But that's okay. It gives us a better ability to see it. All right, so one dog is coming down here and seems to be getting a lot more burgers than the other. I think he's going to get that last one too. Oh, poor guy. All right, so at any time that we can pause this and we can run this method. Let's get burgers eaten. 5. How about you? Only 3. Poor dog 2. Well, that was our simulation. Okay, well that was kind of fun, right? But I want to add another thing to it. And in order to do this, we need to talk about lists. All right. So I want to make our dogs see because right now if I keep running this, you may have noticed this already. The dogs when they run into each other, they just kind of walk right over each other, and that's not cool. That's not really what a dog should do, especially a dog that's hungry. So let's make it to where our dogs avoid each other. So we're going to add another method. So I think before they eat, I'm going to call this avoid other dogs. Okay, of course it's telling me it's an error until I write it. Public void avoid other dogs. And so what I want to do with this method is I want the dog to turn a complete 180 if it's in the neighborhood of another dog. And the method that returns that is called get objects in range. And you'll notice you give it a radius, and the radius is in, I want to say the radius is in cells. Let's take a look at this. Yeah, it doesn't, yeah, in cells right there. So it is in cells, which for us, we're having, I think, one pixel for cell. So it doesn't matter if it's cells or pixels, but that'll matter with other projects. Okay, so we give it a class along with the radius to look at. And it returns a list. And notice it's java.util, not java.lang. Different package, very popular one though. And you'll notice it has an A in these angle brackets. And those are called parametricized classes. So they're using what are called generics, and they're super cool and they're super powerful. What they do is they create a list of that specific class type. So earlier when we were doing get one intersecting object, you'll notice it returns an actor because that's all it can do. But once you start using a list, we can respond. It can return exactly what I want. So I'm looking at a list of dogs. It's going to be exactly dogs. All right, so let's go and do it. First things first, though, in order for me to use this that it returns, I need to import it. So I'm going to say import java.util, and I could say .star like I did with the Greenfoot, which gives me all of util, but it's kind of prefer to just do one thing at a time. So I'm going to say java.util.list. Okay, so here's how we say that. We're going to have to type it. Remember, everything needs a type when you get in a variable and then a variable name. But this is new. In Java, you have to put in these angle brackets, these little alligators, whenever you have these parametricized types. So what type of list is this? This is a list of all the dogs that are within a radius. So I have to put the class type there. And I'm just going to call this other dogs. And it was, I've already forgotten the name of it, right? It was get objects in range. Get objects in range. We're going to give it a radius. And, you know what? I think, it needs to be a pretty big radius, but I would like to be able to easily adjust that and maybe even make different dogs more scared than others. Like if this dog's more brave, then the other dog will turn around before it will turn around. So that's going to be really fun to play with. So let's make this I'm going to call this scared radius. And we'll have to make that variable. So other dogs, and then I have to give it the class type, and of course we're looking at dog class, right? So before it gets mad at me about the scared radius, let me go make that private. The radius is an integer, scared radius, and for now I'm just going to say scared radius equals 50. So all dogs will have the same scared radius, but we can change that, and we'll look at how that's done later. And it could really affect our simulation, right? Okay, so that looks good. All right. Lists. There are several different commands you can do. They work pretty much just like an array, but instead of using square brackets to get a specific one, you use .get. So other dogs .get 5 gets me the dog at index 5 in the list, which is actually the 6th dog because it starts at index 0. You can also add a dog, and you just add a dog just like that, and you put in some dog there, okay? So you can add to the list. That's different than arrays, right? With arrays, you make it, and then you're set. A list gets bigger or smaller if you add, or if you remove at a certain index. So I can remove an item from the list, right? I can also add at a specific index. Like if I had a list of dogs, I can add a specific dog at index 2. I can, if I just say add a dog, it will add it to the back. I can remove at a specific index, I can get at a specific index, and I can finally set at a specific index, which will actually return the dog that's currently there and replace it with the new dog I put as a parameter. So let me just go over those right quick, and I will make a sheet for you to study with this, because these are super important, but I want to make sure we have them. Pretend I have a list called list. I have list.get index returns the item at index. We have list.add, and I'll just call this item. Adds item to back of list. We have list.remove, and you give it an index. Removes and returns it, the item at that index. We have list.set. You have to give it an index and a new item, and it removes old item and sets new item at index. So we have get, we have add, we have remove, we have set, and you don't have a length. Length is how many items is in your array. Size is how many items is in your list. List, super helpful. You can type them as different things. They grow, they shrink. You don't have to worry about the size when you create them because they grow for you. You don't have to remember square brackets. They're just like our methods that we love. Dot and call the method for them. Dot size returns the size of the number of items in the list. So I think that's pretty much all the methods that you need right there. There certainly are others, but those are the ones that are key to being able to use it. And I will definitely make you a cheat sheet and attach it to here. So that's list. Now, for now, I just want to know if the size of the list of dogs. So if we're around a bunch of dogs, we're going to behave the same as if we're around just one dog. So all I really want to know is if the size of this list is bigger than 0. Okay? So all that work, and we're not going to use any of that right now, but we will eventually. So if other dogs dot size is greater than 0, then I need to turn around. So I'm going to turn 180. And that's it. That's the method. I know I talked a long time about lists, but they are unbelievably important. We'll be using them constantly, so I wanted to make sure I went over them at least some degree. All right, so there it is. And let's give it a try. I'm going to populate it with some burgers. I'm going to put I don't know, how many dogs should we put in there? How about 4? Okay. Go dogs. Go dogs go. Oh. So 50 is apparently not that big of a radius. I think it's barely bigger than the object itself. You do see that they are reacting, but I think they probably need to be a little bit larger radius than that. But now we've got a little bit more interesting of a simulation, and our dogs don't walk over each other. And it's kind of mesmerizing to put a bunch of dogs here and watch them react to each other. All right, so the last thing I want to do, though, is I want to make our constructor a little bit different. I would like very much so to be able to set that scared radius. So I'm going to call it scared rad. So now when we instantiate a dog, we'll have the option to set that radius. And I think it's going to be interesting to see what kind of effect that has. So he brings up our familiar little tool here. So this one here, I'm going to do 75. And then I get to put it down. And then I'll do another one with, let's do 150 on that one. And I'll do another one that's really scared, 250. And this one here will be like not very scared at all. Just enough to keep it from intersecting another dog. And then let's do 125 on this one. Okay, and I'll put some burgers out there just in case we want that. But you could also just look at how the dogs behave. Okay, let's run it. Let's see what happens. Uh-oh. We got one that's stuck. Oh, he's just panicky. That one's stuck too. They're absolutely. He's locked in panic out of fear of this dog. Oh, locked in panic. That's interesting. So what seems to happen is that because the other dog keeps coming closer, the dog that is more scared tries to run away, but then because it's detecting another dog still close, will turn around again. So it's just kind of locked in that panicky back and forth shake. So it'd be interesting to kind of explore that and see how we could code it to where that doesn't happen. There is a way to detect which direction the dog is and then move away from it. So that would be interesting to do. We could get the dog that we are closest to, which I believe it's going to return the dog that it's closest to. Well, actually, it doesn't say, but I want to say that's the way it works. So then we could. So we've got actor. We can get the X and Y of that actor. And then what we could do is we could turn towards that X and Y. And then turn a full 180. Now that's not gonna keep us moving these rectangular ways that we have been, but that would be interesting to do. We could also get the dog's rotation and use that, but you can see all this different kind of coding, and you notice I'm not doing it because these are things I want you to think about and to try out. But it would be interesting to make the dog run away from the other dog, but it's gonna mess up our rectangular movement, and everything's gonna get more interesting. So I'll tell you what I'm gonna do. I'm going to stop the video and try coding that right now on my own because I'm very interested in it. You've got an assignment to do. So until next time, take care.